So how can we actually use the critical path method? And perhaps more importantly, what can you expect to be tested on regarding the critical path on the PMP exam? Well, the critical path method, or CPM, uses several different factors for each activity. These include the early start date, the late start date, activity duration, total float, early finish, and late finish, as well as, naturally, the name of the activity in question. Units of measure for each of these different 6 values are typically project days. However, for longer projects, you could see weeks, months, or other units substituted in. However, for our purposes as well as for those of the exam, you can safely assume that each of these 6 different factors that we'll be discussing will be using days as their units. Now, the early start date is the earliest time that an activity's work may begin. For the first activity in a project, this is on day 1. Now, you can calculate an early start date by taking the predecessor activity's earliest finish date and adding 1 to it. So again, if it's the first activity on the project, there is no predecessor early finish, so you would use 0 and add 1 to that. However, if you've done an activity that took 7 days and you're trying to figure out what the earliest start date would be for the next activity, well, the early finish was 7 on the previous, add 1. On day 8, you'd be able to use this as your early start. Of course, activity duration is how long an activity is expected to take in order to be completed. We don't actually calculate this here, but instead we've already estimated it using the Estimate Activity Durations process. As for the early finish date, this is the earliest that you could expect activity work to be completed. To calculate this, you want to take the early start date, add to it the activity duration, and then subtract 1. In this case, we're simply getting rid of that extra day that we have to add into the schedule here. So, for example, we said that the very first activity on the project couldn't begin work until day 1. However, if it's only a 5-day activity, then when will we finish? Well, we would finish on day 5. We have to take that 1 back out that we used in the early start. The late finish date is actually the next one that can be calculated. In this case, this would be the latest that an activity can be completed without causing a delay for the next activity in line. You calculate the late finish by taking the late start date of the successor activity and subtracting 1 from it. In other words, we have to finish this activity no later than the day before the next one is set to begin in order to not cause any delays in our schedule. The late start date, on the other hand, is the latest that an activity may begin without causing a delay in its successor. Now, you can calculate the late start date by taking that late finish date, subtracting the activity duration from it, and then adding 1 for the same reason that we subtracted 1 when we calculated the early finish date. Finally, total float is the amount of time that an activity may be delayed from its early start date without delaying the project at large. We don't actually visualize free float in this particular arrangement, although it can also serve its purposes as well. To calculate total float, subtract the earliest start date from the late start date. The relationship between the late start and the early start date has baked in what the activity duration will be, what the finish dates might look like, and therefore we'll know how many extra days we might have between how long an activity will take and how long we have to complete that activity.